This is lesson 54 of the Quantum Mechanics mini lecture series, Matrices Part 1. So when dealing with many equations involving lots of variables, it can often get quite messy. So let me show an example. Suppose you have something like this. Okay, you have three sets of equations, and the variables, the quantities in this case are A, B, and C. Very messy. Let's suppose you need to find out what A, B, and C is. How would you do it? We can use a computational program like Wolfram Alpha. But there's another way to solve these equations. Simultaneously, in other words, at the same time. This involves the use of a matrix. A matrix is basically an array of numbers. Matrices is the plural for matrix. Matrix is singular. So in this example here, here's how you would write this as a matrix. 1, 2, 3, 4. So I would just remove the A, B, and C. Take the first column to be the A, second column to be the B, third column to be the C, and the last column to be the solution to the equation. So that's for the first equation. Second one is 5, 6, 7, 8. Third one, 9, 10, 11, 12. And I would put a massive bracket around it. Sometimes you might see a line here separating out the variables from the solutions, but that's how you would do it. So this is actually a 3 by 4 matrix. This means by. It doesn't mean multiply. So when someone says you've got a 3 by 4 matrix, you've got a matrix that's got 3 rows. That's how many rows there are. By 4, there's 4 columns in this case. So there's 3 rows and there's 4 columns. Right? It's a 3 by 4 matrix. If you had something which looked like this would be a 2 by 2 matrix. It's got 2 rows and 2 columns. As an exercise, try and rewrite this as a matrix when you get the time. It's just a good exercise. And just like vectors, matrices can also be added, subtracted, multiplied, etc., etc. So let's suppose we've got 2 matrices here. And this. To add them, all you need to do is basically add each element with its counterpart. Here's how you would do it. So if you were to add these two, you would just go 1 plus 8, 2 plus 9, 3 plus 10. So I'm taking each respective component here, adding it together. 5 plus 11, 6 plus 12, 7 plus 13. I'll just work out each individual component. 1 plus 8 is 9, 2 plus 9 is 11, 3 plus 10, 13, 5 plus 11 is 15, 6 plus 12, that's 18, and 7 plus 13, that's 20. And there's your end matrix end result. There are also instances where a matrix can be a square. In other words, it's got the same amount of rows as columns. Sometimes we use the notation M for rows and N for columns. An example is this. This is actually called the identity matrix. It's got a special name, identity matrix. It's sort of like multiplying by 1. It's got 1s along its diagonal. You can also have high dimensional identity matrices. So something like this. This is a 3 by 3 identity matrix, and so on and so forth. That's a 2 by 2 identity matrix. That's a 3 by 3 identity matrix. But it's just a nice way to express how in matrix form an equivalence of like multiplying by 1. So that's matrices in a nutshell.